So chapter 10 is going to be all about working with quadratic equations and quadratic functions. So you should remember we talked about quadratics at the beginning of the course back in chapter 6. When we talk about a quadratic function or a quadratic equation, that just means it involves x squared, right? Somewhere in the function or in the equation is an x squared value. Now in chapter 6, we learned how to solve quadratic equations, but only by factoring. Okay, so just to kind of remind you how we did that, if we were going to solve by factoring, the first thing that we always did was we made sure to set the equation equal to 0. So like if I were going to solve x squared is equal to 16 by factoring, the first thing I would do is subtract the 16 from both sides, and I would rewrite this as x squared minus 16 is equal to 0. Now, our next step, once we set it equal to 0, was to factor it. All right, so in this case, my constant term is negative 16. All right, I'm just going to start both of these with an x, since I just need to get x squared. So I would be looking for two numbers that multiplied to give me negative 16. That's the constant term here. But they would have to add and give me 0 because there is no middle term. There's no x term in this particular equation. So those two numbers are going to be positive 4 and negative 4. So this would factor, again, this is using methods from chapter 6, into x plus 4 times x minus 4. And then once we had this thing factored, all we had to do to solve it was take each factor and set it equal to 0. So that would mean I would take x plus 4, set it equal to 0. I would take x minus 4, set it equal to 0, and then I would just solve each one. So over here, if I subtract 4 from both sides, I get x is equal to negative 4. Over here, if I add 4 to both sides, I get x is equal to 4. So these would be the two solutions to my quadratic equation, x squared is equal to 16. And I can plug them in and I can check it. All right, now, what we're going to be looking at here is a more condensed way to solve this, which is by the use of something called the square root property. And we can do this now that we've talked about all these different properties with roots. So what the square root property says is if you have an equation where a squared is equal to b, then basically you can solve this by taking the square root of both sides. Now when you take the square root of something squared, right, that's going to get you to just a. And then the main thing about the square root is you have to remember that technically there is both a positive and a negative square root. So for example, if I wanted to use the square root property to solve that same equation, all right, what I would do first is I would say, okay, I'm going to take the square root of each side. So I'm going to take the square root of x squared, and I'm going to take the square root of 16. Now again, when you take the square root of something squared, it's kind of like those two things cancel each other out. So this is going to leave me with just x. But I want to remember that when it comes to the square root of 16, there is technically a positive and a negative. So when I state my solution here, I'm not just going to include 4, I'm going to include plus or minus 4. And that actually refers to two separate values, right? One would be positive 4 and one would be negative 4, which is the same solution that I found when I solved by factoring. Now, you can do this with any type of equation as long as you can isolate x squared. You have to get the square part by itself. So if I wanted to solve this equation, for example, I cannot take the square root of both sides until I isolate the square term. So if I want to get that x squared by itself, right, the first thing I would do is I would need to add 4 to both sides. All right, you always do your adding and subtracting before you're multiplying or dividing. Now that would give me 2x squared is equal to 4. Then to get the x by itself, or to get the x squared by itself, I would divide both sides by 2. And that would tell me that x squared is equal to 2. At this point, I'm ready to use the square root property because all I have on one side is x squared. So when I take the square root of both sides, right, I'm going to take the square root of x squared. I'm going to take the square root of 2. And then I just want to remember that when I take the square root, there is a plus or minus. So the square root of x squared would be x. And then over here, I'm going to be left with plus or minus square root of 2. And square root of 2 can't be simplified. So all I could really do here is write this out as 2 solutions. One would be the positive square root of 2, and one would be the negative square root of 2. All right, and that would give me the 2 solutions that would satisfy the original equation. So it's the same square root property. You just have to make sure you get the x squared by itself before you go through and apply that property. All right, so let's say we wanted to solve this one. Now this one looks a little bit different because it has a binomial being squared, but the property can be applied the same way. As long as you make sure that what you have on one side is all being squared, then you are ready to apply the square root property. So right here, when I see that everything on this side is in parentheses and is being squared, that tells me I'm ready to go ahead and take the square root of both sides. Now, if I take the square root of y plus 6 squared, that will equal the plus or minus square root of 16. Now, again, when you take the square root of something squared, those kind of cancel each other out. So here I'm going to be left with just y plus 6. And then over here I can simplify because the square root of 16 is 4. All right, now, at this point, because I had y plus 6 being squared, I have one more step to do here as far as getting y by itself. And that would be at this point to say, okay, I need to subtract 6 from both sides, right? If I'm going to solve this thing and get y by itself. Now, whenever you have a plus or minus, it makes more sense if you put the other number in front. So instead of writing this as plus or minus 4 minus 6, I'm going to write this as negative 6 plus or minus 4. Because then I can separate this and get my 2 solutions, right? If I look at the plus, then I can say, well, one solution would be negative 6 plus 4, or negative 2. If I look at the minus, then I can say, well, my other solution would be negative 6 minus 4, or negative 10. And at that point, I would have my 2 solutions. All right, what makes this a true statement is if y is equal to negative 2, or if y is equal to negative 10. All right, so again, the main thing is to make sure everything on one side is being squared before you apply that square root property. All right, now this one is very similar to the one that I just did, so I would encourage you to work through that one and then double check your work with my posted notes under the Course Materials tab. All right, let's skip ahead to this one. All right, now, when you look at this, right, you see that you do have something being squared. What's being squared is this whole y plus 4. So all that's fine. It's in parentheses. It's all being squared. And if that was all that we had, we'd be ready to go ahead and take the square root. But because we have something else over here that is outside of the parentheses, right, the 3's not being squared, the first thing we have to do is move that, right, get rid of that. So if there's something out in front of whatever's being squared, the first thing you want to do is divide both sides. Because what that will do is it will get me to a point where I have just y plus 4 squared, so that everything on the left-hand side is being squared. And on the right-hand side, I now have 32. All right, and this is what you want. You want to get to a point where you have something squared all by itself on one side. And when that happens, then you are ready to take the square root property. All right, you just want to remember, this is the plus or minus square root of 32. Now again, square root and square, they kind of cancel each other out. So I'm going to be left with just y plus 4 here. And then 32 is not a perfect square, but remember we can simplify, right? If we can write it in terms of a perfect square. So 32 can be written as 16 times 2, which means I could go ahead and pull out the square root of 16, that's 4, and I'd be left with just the square root of 2 underneath that radical, right? That's what we looked at in chapter 9. And then again, you're not finished until you get the variable all by itself. So this is kind of like the one I just worked. We aren't left with just y. We're left with y plus 4. So to finish this out, we need to subtract that 4 from both sides. And again, whenever you have the plus or minus, it's going to make more sense to put the other number in front. So instead of plus or minus 4 square root of 2 minus 4, move that negative 4 in front and write this as negative 4 plus or minus 4 times the square root of 2. Now again, you want to understand that technically that's two solutions that you're looking at there, one with the plus and one with the minus. So if I wanted to write this as two separate solutions, and a lot of times you will be asked to write this as two separate solutions, the plus would give me negative 4 plus 4 times the square root of 2. There's one solution. The minus would give me my second solution, which would be negative 4 minus 4 times the square root of 2. And notice these are numerical values. I could plug this into my calculator. Negative 4 plus 4 square root of 2. It's just that I would have to use an approximation, and I don't want to do that here. I want to keep it in its exact form. So if I get to a radical that I can't simplify anymore, I'm going to leave it just like that. All right, and I do have one more example in here for you, which is similar to one that I've already done. So this one, just like the one I mentioned before, this one's going to be very similar to one that we've already done. So again, I want you to work through that one, think about what you'd need to do, and then you can go back and check your work when I post my notes later on. Now, this is what you're looking at in 10.1a. So you're going to notice in Hawks you have a 10.1a and a 10.1b. So what I would like for you to do is kind of pause here, just work with the square root property, right? Only look at the information in 10.1a and make sure that you're comfortable with that before you move into 10.1b. All right, so I'm going to pause right there, let you go and work in 10.1a, and then I'll post a second video after you do 10.1a. I want you to come back and watch the video for 10.1b.